from KMA. So today my presentation is about the marine meteorological services that we provide at KMA. My name is Seung-hyup Yu and I'm a director at Marine Meteorology Division at KMA. So as you know, Korea is a very small country, but we have 3 oceans surrounding the peninsula, and we have 4 distinct seasons. So different regions have very different climate. And in the summer, we have like 2 or 3 rounds of typhoons hitting the peninsula. So we are a small country, but we suffer diverse climate situations. We also have drought. Also, we have the heat wave, drought, Asian dust, cold wave, all those severe weather events. We also have heavy rainfall, heavy snowfall, and typhoon. So it's like so many diverse climate events happening in such a small country. So what we are trying to do at KMA is to protect the people from those weather crises and give the people with proper information so that the Korean public can be prepared properly. So the mission of KMA is to provide fast and reliable weather information. That's the biggest mission. And our visions are to provide reliable information that meets the needs of the Korean public. And according to that vision, we have 5 strategies. So they are not strategies for different areas, but they are just based on functions. So we have forecasting and enhanced values and climate-related issues. So those are the strategies that we have at KMA. So marine climate forecast that is incorporated in all those 5 strategies. So this is the map of Korea. So compared to the land size, we have such a vast ocean. So three oceans surrounding the peninsula, and we have like 3,200 islands, and 27% of the Korean population are living in the coastal area or on islands. And the ocean size is like 4.5 times larger than the land size. So at the Ministry of Oceans, the keyword of the ministry is the safety of our waters and what kind of ocean-related services that we can provide for the public safety. So if we can interpret the meaning of oceans in terms of socioeconomic terms, well, Korea had the economic growth led by import and export, and 98% of imports are coming through the ports, meaning they come through ships. So that is why the port-related climate forecast is so critical. That is how we came up with that concept, and the climate-related services for fishers have also evolved. So many of these fishers have very small-sized vessels. So that is why the safety is so critical. The information about climate that they get are so critical for their safety because their ships are so small. So we call them as the information marginalized people because they're out there in the sea. So we always try to find out better ways to reach them. So because of that, here you can see there are many vessel-related accidents. So for the past 5 years, from 2016 to 2020, we had a lot of ship-related accidents. So 18.4% of those accidents were related to the weather. So they were not caused by the errors in the function of the ship. They were all mostly caused by the accident. And these accidents mostly happen to small-sized vessels. So they were caused by abnormal high wave heights and swells, localized tsunamis, and etc. So if you look at what happened before 2000 and after 2000, if you compare those graphs, you can see that disasters caused by heavy rainfall did not go up a lot, but after we entered 2001, we had the climate crisis. So we had a lot of strong winds, especially typhoon, and many accidents were caused by those strong wind-related accidents. So in case of typhoon, it is one of the most critical factors that cause the oceanic accidents. So as you can see, Korea is a peninsula surrounded by oceans on three sides. So we have a lot of snowfalls and heavy rainfalls happening in the ocean. So how to monitor the interaction between the ocean and atmosphere is one of the key missions of KMA. So here you can see there are damages caused by climate-related disasters. So we have about $1 billion in property damage per year caused by those weather disasters. And for the recovery cost, it is like twofold of that. So it's like more than $2 billion. And most of those disasters are caused by typhoons, followed by a heavy rainfall and then heavy snowfall. So various climate disasters are affecting the peninsula to cause a lot of social and economic damages. So when typhoon hits the peninsula, in the coastal area, you can see that it causes this high wave height and hail and localized tsunami and storm surge and strong wind affecting many people living in the coastal area, which is like 2.7% of the Korean population. So simply put, when we have done a very simple research, we found that it's very important to predict the typhoon and other weather events to minimize economic impacts. So if we can have an accurate forecast on the sea surface temperature, we can have a lot of saving, like 2 billion won of saving every year. And also, by having an accurate water temperature forecast, we can also identify the fish distribution, where the fish is located, which would lead to better fish catch production. So here you can see that there can be a weather forecast for fishermen, but also for other people in the coastal area. So for this overall marine weather forecast, we first need to do the monitoring and do the analysis. And out of that analysis, we can come up with the forecast data and then deliver it to the people who need the information. So those are the four steps for the weather forecast. So for the basic functions of marine observation, at KMA, we came up with a discus buoy in 1996. That was the beginning. And then we came up with the monitoring vessel in 2000. And after that, we came up with a bigger sized buoy called Nomad buoy in the East Sea. We also used stations like unmanned stations and drifting buoy to observe the ocean. And since 2017, we started to have a smaller sized buoys. As of 2019, we had 122 stations, and by 2023, we will increase that number to 257 stations. So we have 120 marine observation stations. They are mostly comprised of ocean data buoy, coastal wave buoy, and long wave monitoring stations and wave radars and etc. And they are used based on the spaces of the ocean or the characteristics of the ocean. So simply put, from starting from the near coast to offshore, we have different equipments used. So for the near coast, we have wave radar and lighthouse AWS and small-sized buoy called the coastal wave buoy. And in case of offshore, like distant water, we have bigger sized buoy like discus buoy, nomad buoy, and also we use vessels to monitor the offshore. And for the marine meteorological observation, the toughest part is the maintenance. As you can see at the bottom of this slide, we can have like a vessel approaching or hitting the equipment to cause damage to the equipment. We call that as vandalism. However, we don't have a clear ways to prevent those vandalisms. So what we did at KMA was like this CCTV, like a black box CCTV installed on buoy. So currently the satellite communication is very cheap. So we have installed this. So in 2013, we had a big sized buoy in the East Sea being disrupted, and we had this black box CCTV, and we took a look in the black box, and well, they didn't know that a camera was shooting them. But what we found was that there was a vessel that intentionally disrupted our buoy. So we have had a claim for the compensation. This buoy, it costs like 1 million won. So after those claim filing, compensation filing, we had reduction in vandalism. So the most ideal way to do the ocean data monitoring is to have the ocean buoy. So currently, what we are doing is to have the data transmitted in every 30 minutes. So this nomad buoy, it is located in like a very deep ocean, distant ocean. And for discus buoy, it is mostly located in the West Sea or South Sea. And this is like $1 million in price, and this one is like $500,000 in the price. So they are both very expensive. So you can see those are the buoys that we have scattered around the ocean of Korea. So not just in the coastal area, but also in like more distant waters. We have like this 10-meter discus buoy located in the West Sea, and in the bordering oceans. Well, the situation there is not very accommodatable. So in those areas, we have like a bigger sized buoy located there for the ocean monitoring. The biggest benefit is that this one, it is very stable, has very accurate data. However, if there is like any accident, it takes a long time for repair and the maintenance is not easy. So for buoys, we use the Inmarsat satellite to transfer data to our headquarters. And as I said, buoys are very expensive, and it is not practical for us to have them installed in all sections of the ocean. So we have developed a coastal wave buoy, which is cheaper. So this is based on CDMA communication. It is not that expensive. It's just the a mobile communication method. So this coastal wave buoy is of course installed in the coastal area. So it's like a $6,000 per unit of this buoy. So it's relatively cheaper than other buoys. Benefits of this buoy is that it's relatively cheaper and domestically developed, and it has relatively nice quality of data. However, as it's very small sized, it's very vulnerable to accidents and it has to have the battery changed every 6 months minimum and 1 year maximum. It does not use the satellite communication but uses the CDMA communication because it's located in the coastal area. So to recap, we have the coastal area and offshore and high sea, different ocean areas that should be monitored. And in the distant sea, there are some gaps in the monitoring stations. So that is why we use other equipments as well to compensate for that. And that is the drifting buoy here we use. And the other one is the vessel AWS. For vessel AWS, well, at KMA, we have a vessel, but one vessel is not enough to cover all the ocean. So there are like other affiliated agencies like Korea Coastal Guard and ferry ships like passenger ferry ships and etc. So we install our equipment on their vessels with our expense. And as they go around the ocean, we can collect information we need by using the equipment installed on their vessels. In case of the Korean Coastal Guard, they don't have a fixed route. So we also use a ferry that it goes through a regular route, like a ferry that goes between Korea and China. So we use them, we collaborate with them to install the vessel AWS and use the satellite communication to gather data from those vessels. So for vessel AWS, there are many benefits. We don't need to have our own vessels. We can use other agencies' vessels. However, the disadvantage is that we cannot go to a specific location we want to go. We just have to follow the route that those vessels are going. And in case of the drifting buoy, this is how it looks. It's not located in a specific place, but we just throw them into the ocean and they just float on the ocean for their lifespan and just drift on the ocean. So it's like a consumable. It is not maintained, the battery is not replaced, but just is drifting on the ocean until the life cycle is terminated. So this is like if there is like a typhoon forecast, if we think that a typhoon would happen, then generally we do the forecast like 5 days earlier. So if we think that typhoon would be created, then we throw this drifting buoy in the typhoon genesis location. So this drifting buoy has many benefits. First, if there is like a area or a location where typhoon is likely, that area is very dangerous. So we just throw this drifting buoy there because we don't need to collect it back. That's the benefit, but the disadvantages are that it has low battery capacity and can easily be destructed when it's crashed with other ships. Also, we can lose it very easily. So those are our weather prediction equipment. And based on that, we create the NWP model called the numerical weather forecast and prediction model. We use supercomputer for NWP, and there are only 13 countries around the world with NWP supercomputer because supercomputer is so expensive, like 2 billion won. So very few countries around the world have their own supercomputer for the weather prediction. We renew our supercomputer every 5 years, and currently we are using our fifth equipment. This is like $50 million in price. So it is one of the most expensive national equipment. By using this supercomputer, we can predict the weather height, the wave height, and can look into those coastal areas and the regional areas and the global situation. So we can predict up to 72 hours. So when typhoon is passing certain region, the wave prediction can give alert to people around there. And in the western area, we have this kind of more detailed analysis to identify the accurate wave height. This is in the Jeju Island region. This is in the southern part. This is also the analysis that we are doing by using the supercomputer. Every year, Korea suffers like 2 or 3 typhoons, as I said, and those red dots are where typhoon is generated. So we did the tracking starting from tracking of the peninsula starting from 1961 till today. And for the past 60 years, we had around 200 typhoons hitting the peninsula in the past 60 years. When typhoon occurs, not just the wind wave is high, but also we have the hail or regional tide and storm surges happening. And we also track those climate events. We use those data to identify where the coastal inundation is likely if typhoon hits the peninsula. So these are the data that we use at KMA to forecast where the storm surge could occur. And we deliver the data to the people of Korea. So those red dots are critical points for the storm surge and wave height and tidal height. We do the forecast for those critical points first and then do the forecast on the possible coastal inundation. So you can see that there are those red numbers there. The reason why we need this information is like in 2016, we had a typhoon Chaba going through the peninsula in 2016. And because of this typhoon, we had such a high wave height and storm surge hitting the peninsula as well. So in the south coastal area of Busan, which is the second largest city of Korea, we had this kind of situation, inundation, which is almost like a tsunami hitting the city. So this is called a wave overtopping. So we wanted to give the information and warning to the citizens of this city by having this weather prediction. So these are very fundamental data that we can gather, and what kind of service we provide based on those data is another thing. So first thing we can do is the port weather service. As I already mentioned, 98% of import and export of Korea goes through the sea. It's like for airplane to have safe flight, its landing and takeoff is very important. So the operation of airport is very important. So that's why the operation of port is very critical. So in case of the US, they have a very evolved port weather service. And in Korea, as we have bigger volumes of cargo being handled at the port, we have developed this port weather service. So this is called K-HOPE, Korea Harbor Observation, Prediction, and Dissemination. This is Busan Port, the second largest port of Korea. So we have AWS CCTV visibility meter and coastal buoy. So these are the equipment installed only for the Busan port for more detailed observation. And based on that, we come up with the prediction. However, the port is very small sized. What we do is for the vertical resolution, it is 500 meters. in resolution. So we do the prediction on wave, current, temperature, salinity, sea level, and etc. to come up with a specific port weather service for this specific location. So we deliver the information to other related agencies like the Ministry of Ocean and Vessel Safety Agency and all the other related agencies. So starting from the observation to prediction, you can see that we have created a port weather portal, and anybody who needs the information can access this portal to get the information. And how do we deliver the information to the involved parties? Well, for the inland, we can easily distribute the information through mobile phone because almost everybody has the cell phone these days. But for the ocean, some people might not be reached due to the communication connection. So first, what we used was this fax system, the WeFax system. For specific vessel, we have this wireless fax uh, receiving equipment installed. So it's not just Korea, but other countries started to adopt this with fax since 1960s. However, the problem is that this is very expensive and the data is all just transmitted in black and white. So it has very low resolution. So it's very different from the resolution quality that you can get these days. So the resolution is very poor and only large vessels can have this WIFAX installed. So from a few years ago, what we started to do was this weather voice service. So it's targeting small-sized vessels, like 70 to 80% of vessels that suffer accidents due to weather events. For those small vessels, WIFAX is too expensive for them. So what they use is this weather broadcasting system. So we use this frequency 5.9 megahertz, and we provide the service in 4 different languages, including Korean, Chinese, Japanese, and the service is provided 24/7. This is also a short range service and short range communication. So the quality of the voice sound is not very good, but still it's cheaper. So we started to use that. But there is another one that we have adopted since last year. So this is called a GK2A. This is using the Chilean satellite. So there is the SDAS communication channel, and we thought that we can use this SDAS communication channel to reach the vessels that are hard to be reached by using existing communication channels. So by using SDAS, we have installed a new kind of antenna to be installed on vessels. So this is the coverage area of ESDAS. So any vessel with this kind of receiver can get very high resolution climate information from KMA free of charge. You can see that the coverage is including most of the Southeast Asian countries. So we are also having discussion with Indonesia to export it to Indonesia. And this service was introduced last year, and we have introduced it to the International Meteorological Service Agency. Also, we have this website named Ocean Portal Service for 6 areas, including port, sea route, leisure, fishery, disaster, and security. We provide information about the weather situation of different ports and routes of different vessels or ferries This is like a customized ocean information service portal. And later, we will have the fisheries cooperative making a presentation. And this slide shows an app created by the Fisheries Corporation. So we have connection with their app so that our information can be also delivered through their apps. This is the last part. So my recommendation for Bangladesh for its way forward in terms of the marine meteorology service. So there are five changes, three steps needed. So as I said, we started the first observation since 1996 and then evolved to this date. So what is very important is to have the basic foundation for observation and prediction, but they are very expensive to create and maintenance is not easy as well. So what we are suggesting is rather than using a fixed buoy, it is better to use vessels or floating buoy because they could be easier to implement. And based on the characteristics of your marine condition, you can have customized observing network created. So when you have those foundations ready, what you need to do is to use the data to predict the weather. In case of Korea, we have one of the top 5 prediction system. But I think that in case of Bangladesh, due to the insufficient infrastructure, I think having this kind of NWP model would be quite hard. What you can do is not to look at the entire globe, but just look at your specific region to narrow down the region needed to be observed or analyzed so that you can reduce the cost. So this kind of localized weather forecast would be more adequate for Bangladesh. And for the delivery method of the data, you can have the satellite service and also the mobile communication service. And you can also use the old ways like WIFAX or SSB Marine, but maybe it's better to adopt the newly developed methods. So what you would need eventually is like an integrated weather forecasting technology that you can predict all the marine weather events and have the accurate prediction of the seawater temperature. And I believe that based on that, you can have a special marine weather information generated. And to make that possible, what kind of cooperation or technical assistance would you need? First, I think that first thing you need is the marine observation by installing these equipments or buoys, and then have the infrastructure to assist the operation of those equipments. And to operate those facilities, you need to do the education and training, the capacity building for related people. So if you can have those done, I think that you can have more accurate marine weather forecast. This is the last slide. So for the marine weather information, well, it's used in all sectors of the society. It is used for fishery and also for disaster prevention, construction, leisure, and security as well. So having a solid system in place is very critical for the entire nation. That's the end of my presentation. Thank you.